Hey guys, we're on page 26 of your binder. If you don't have page 26 ready, pause, go and get it, and then come back to the video. So these two pages are going to talk about variability. Variability looks at a set of data and talks about how similar the numbers are to each other or how different they are. And we can give it a number value. We can actually measure that. And so it's called variability. A measure of variability is a way of describing how far apart the data is. It can also be used to describe how much the data deviates. Deviates means gets away from or moves away from, and how much it moves away from the center. The first thing we're going to use is called the interquartile range, and that comes from a box plot or a box and whisker plot. The interquartile range is a measure of variability that splits the data into 4 equal quartiles. It represents the middle of the data, and it can be found by the following. We know that we have to order data from low to high. We have to find the median. And then we're going to find the median of the upper and lower quartiles. And then we're going to subtract to find the IQR. So if you look at a box plot, we're talking about this middle section right here. We want to know how far apart the beginning and the ending of that box are, because the middle half of the data is in there, and we know that the middle of a set of data is usually where the normal is and the average are, and so we want to know where those begin and end. So that's what an IQR does. Here's something important. A small IQR means the data is close to the median, and that's pretty important. In this case, small is usually better. You want a small IQR. That means all of your data is pretty similar to each other. So let's try this out. The data below represents a different cost of a camera at a local photography store. So first you're going to put your data in order from low to high. One, two, three, four, five, six, seven. 1, 2, 3, 4, 5, 6, 7. Okay. Our minimum price was 28, and our maximum price was 108. The median is the middle number, so that would be 59. All right, then we do the median of the first half of the data. That's called the first quartile, and that's going to be 36. And then do that again up here. And then our IQR is the distance from these two quartiles. So from 71 to 36 is going to be 35. So that middle set of cameras that's in that middle 50% are $35 different in price, which is actually kind of a big range there. All right, let's do it again. The following data represents the number of cars running a red light in an intersection at these two streets over a period of 2 weeks. I actually want you to pause the video. I want you to put the numbers in order, find your median, find your IQR, and then come back and check your work. Okay, once you've ordered them up and found your median, you'd realize that we need to find what's in between 12 and 14. So our median was actually 13. And then from there, you could find the median of the lower half. That was 9. So that's your first quartile. And 18 would have been on the upper side. Notice how there's 3 numbers in between all of these cuts. And so that tells us distributed, and we picked the right quartiles. And then for our IQR, we took our upper quartile of 18 and our lower quartile of 9. And so our IQR is 9. So those are our 2 measures for that one. All right, scroll down to page, or flip to page 27. The other big way to measure variability is called the mean absolute deviation. This is a sixth grade topic. It should have been previewed, but we'll recap it because a lot of people said that they did not remember doing it. So it's the mean absolute deviation. We've seen mean before. That's an average. Absolute means we're not going to worry about positives or negatives. And deviation means subtraction. We're going to deviate or move away. So we need to know how far. We're going to abbreviate that as MAD, M-A-D. This measures the spread of the data in relation to the mean. Remember on IQR, that was the median. Now we're comparing to the mean. So first we need to calculate what the mean of the whole data set is. Then we're going to find the difference between each piece of data and the mean. Take the absolute value, which is just a long way of saying we're not going to worry about positive and negative. Sum the, I'm going to put ab value, and then divide by the number of pieces of data. A MAD close to 0 means the data values are close to the mean. So again, low MAD is usually a good thing. All right, let's calculate the mean, or excuse me, the mean absolute deviation for number 3. 7 different students were asked the number of family members in their household. Use the data to complete the table. So our first step is to calculate the mean. So that's when we add them all up and divide by how many there are. So we've got 3, 2, 4, 2, 5, 6, and 2. We add those up. 3 and 2 is 5, plus 4 and 2 is 6. 5 and 6 is 11, and then another 2. That total is 24. We're going to divide by how many numbers we added, which was 7. So our mean is about 3 and 4/10. I'm going to round to 3 and 4/10. All right, the deviation is how far each of these numbers is off of 3.4. So take 3.4 and subtract 3. And that's 0.4. We don't care if it's positive or negative. All right, 3.4 minus 2 is going to be 1.4. 3.4 minus 4. And again, we don't care about the negatives. So that's 0.6. All right, we've done this one before, minus the 2. So that's 1.4. 3.4 minus 5 is 1.6. Again, we don't care about the negative. 3.4 minus 6 is 2.6. And 3.4 minus 2 again is 1.4. So once we've got all of these, we're going to do the mean again. So we're going to add them up. We get 9.4. We added 7 numbers. We divide by 7. We get about 1.3. So what that tells us is the mean number of family members is 3.4, and each family asked on average is about 1.3 people off of that, which isn't really big. 1.3 is a pretty small one. So our mean absolute deviation is 1.3. So most families are about one family member above or below the mean. So the mean was about 3, a little bit more than 3. Most families were between 2 and 4. So not too much. Too much of a difference anyways. All right, What I want you to do is I want you to pause the video. I want you to do the same thing we did for number 3, do that in 4. The only difference in this one is there's one less column, and basically it's this column that's missing of the person that was asked. So this is your data set, the green M&Ms. So in the science class, an experiment required the number of M&Ms in a small package, and these are the numbers that they had that were green in each of their packages. So find your mean, subtract, and then find your mean again. Pause, do that, and then come back. All right, for number 4, the green M&Ms, you should have gotten a mean of 5.8. So if you added all these up, divided by 10, you would have gotten 5.8. And then we use that to subtract all of our data points to figure out how far away from the mean they were. And when you added all these up and divided by 10, you should have gotten 3. So our mean absolute deviation was 3. And our last question asked, does the MAD represent a large or small amount of variability and why? So 3 doesn't seem like it's a really big number, but if you look at our data set, our numbers only went from 2 to 11. So having a variability of 3 is kind of a big deal. So in this case, yes, there is a lot of variability. All right, so big ideas here for these 2 pages. We're measuring variability. If we use the median, that's called the IQR, interquartile range. And if we look at the mean, that uses the mean absolute deviation. So it's 2 different measurements for how different a set of data is. All right, this is the end of your notes, and I will see you later. Bye.